Hello everyone, my name is Eder Udiosigi.
And we're from the IEEE student branch of the Cullen College of Engineering, and today we're going to be showing you the Oersted experiment. Before we start our experiment, let's first go over the materials we'll need and some safety guidelines.
You'll need a breadboard, bowl of water, bottle cap, wire cutters, wire strippers, a 22 gauge solid core copper wire, insulated of course, 4 AA batteries, a battery holder, a paper clip, and a pencil.
Next, let's go over some safety guidelines. First things first, do this experiment with parental supervision. Don't leave the power connected for more than 1 minute so the battery doesn't get too hot. Don't cut yourself. Be very careful and ask for your parents' help when working with the wire cutters or even with the needle. Clean up any spills you may make from the bowl of water. And lastly, and most importantly, do not put the circuit into the water. Now, let's go over why this experiment works. This is the Earth's magnetic field. The south magnetic pole is at the top of the Earth. The north magnetic pole is at the bottom of the Earth. Now, we know how magnets work. North is attracted to south. North is not attracted to north, and south is not attracted to south, but they are attracted to each other. So, the north part of our compass is attracted to the south magnetic pole because north attracts south. This is why our compass points upwards. According to Ampere's law, if we have an electric current, we will create a magnetic field. So if we have a current flowing in the upwards direction, like in this wire, we will create a magnetic field like this, curving around the wire. Now this is the coil we're going to be using in our experiment. The coil acts as multiple wires, and each one of these wires has its own magnetic field. And all these magnetic fields add up to one large magnetic field. So when we put this coil next to our needle in our bowl of water, which is acting as our compass, the needle will align with the coil instead of aligning with the Earth's magnetic field, because the magnetic field in the coil is stronger than the Earth's magnetic field.
Now it's time to build our Oersted experiment. First, we're going to take our wire and our pencil. Leaving some slack, you want to wrap the wire around your pencil about 13 times, making sure you get the coils as close together as possible. Once you finish, you'll slide it off, and it should look something like this. As you can see, the coils are very close together. Now, if you look at the ends of the wire, you can see that, of course, I cut the wire with the wire cutters, but in addition, you'll want to strip the insulation off of the ends of the wires, like where the silver part is on this wire.
Insulation. And so then I'll set those aside.
Next, we're going to take our needle and our magnet. You want to stroke the needle against the magnet at least 20 times to make sure that you magnetize the needle. To test it, take a paper clip and try to pick up the paperclip with the needle. If you can pick up the paperclip, then that means your needle is well magnetized. Next, we'll take our bottle cap. Before doing this experiment, I made holes in the bottle cap so I can easily put the needle through. You'll want to do this with parent supervision. Slide the needle through the holes in your bottle cap, like so. It'll look something like this. Next, take your bowl of water and put the bottle cap very carefully on the surface, making sure that it doesn't sink. Now, let's check the direction our compass is pointing in with an actual compass. So I'm going to take the compass on my phone and see if the needle's pointing in the same direction. And it is. Now let's take our breadboard and our batteries, plug in the battery to the breadboard. You'll want to put the red lead in one row and the black lead in another row. Next, let's plug in our coil. You'll want to do the same thing. Put one leg in one row and the other leg in another row on the breadboard. Then we're going to take a small piece of wire. Make sure to use the wire strippers to strip the ends of this wire. Now we're going to put one leg in the same row as the red wire. And then when we're ready to turn on the experiment, we want to put the other leg of the small wire in the same row as the end of the coil. Before we do that, we want to take our black wire and put it in the same row as the other leg of the coil, like I'm doing here. Now, let's test it out. We'll get our needle in our bowl of water. Make sure to try to center it. And then plug in your small wire to the other end of your coil. Then, being very careful not to drop your coil in the water, move the coil and watch the needle as it moves in the direction of the coil and as it aligns with the coil.